group is Cassidy, Anila, and William, and our project is single replacement reactions. A single replacement reaction is when two different cations switch places or combine with the same anion. A generic equation for this is A plus BC goes to B plus AC. The way to determine if a single replacement reaction is going to occur is through the activity series. In order for a single replacement reaction to occur, the single cation must be higher on the activity series than the cation in the compound. The activity series is shown above. Some other rules for single replacement reactions are that alkali metals will always replace hydrogen in cold water. Magnesium through iron on the activity series will always replace hydrogen in steam. Mercury usually doesn't react, and metals higher than hydrogen will always replace hydrogen in an acid.
The reaction we chose was between copper and silver nitrate. In this reaction, a copper strip is dipped into a silver nitrate solution. The copper replaces these silver atoms, creating copper nitrate and precipitation of silver metal crystals. If we think in terms of redox reaction, we are able to conclude that the contact between copper and silver nitrate solution initiates a redox reaction between the two, in which copper is oxidized to copper 2 and silver is reduced to silver metal.
The next clip will show this reaction. This is our initial copper for our reaction, and this is our original silver nitrate solution.
Okay. And then we drop the copper strip into the solution.
As you're going to see here in a minute, the copper is replacing the silver in the reacting with the nitrate. So the mass of the copper during this reaction is going to go down, and as it becomes copper nitrate. And as you can see, this black, the dark stuff starting to form around the copper strip is the precipitation of silver, and pretty soon that'll start to creep around the whole copper strip.
Takes long.
The reason this reaction is able to occur is because copper, the lone cation, is higher than silver, the bonded cation, in the activity series. Because this reaction takes so long to run to completion, we decided to do time-lapse format. This is a picture of our reaction after the initial 3 minutes that we recorded it. After about 20 minutes, this is what the reaction looks like. The silver precipitate has formed, and then on the copper, and then we shook the glass to discharge the silver precipitate, as you can see here. We came back several hours later to see our reaction, and this is what we got. As you can see, there is essentially no copper left. There's lots of silver precipitate, and the solution has turned blue due to the copper nitrate ion solution. This has been Cassidy,
Anila,
and William. Thank you for listening to our project.